All right, welcome to the lab number 4. Lab number 4 is on double displacement. And so this is the video is to introduce what is double displacement, how to go about writing 3 kinds of equations: molecular equations, complete ionic equations, and net ionic equations. If you have not watched the lecture video on this, you need to do that first, because this lab has a lot of material that overlaps with that. So if you watch that video first, it will help a lot in understanding double displacement. Okay, when it comes to double displacement reactions, what we're going to be doing is we're going to be mixing 2 different chemicals together and then seeing what happens. So if you've read the procedures for the double displacement, you will know that in this lab, what we're going to do is we're going to have a bunch of solutions and we're going to mix them together. Okay, so if you are on the post-lab data sheet, the first box says A, and it's already been filled out for you. And so A, you're mixing together sodium carbonate and calcium chloride. Okay, so sodium carbonate is really made up of anion and cation. The cation is 2 sodium pluses, that's why there's a 2 there, and 1 carbonate anion, okay, which is 2 minus. Notice that with the 2 plus and the 2 minus, the charges are balanced. Okay, it is mixed with calcium chloride. This solution is really a solution of calcium 2 plus, that is the cation, and 2 chloride ions. Okay, so they're separate from each other, and that's why it says Cl2. Okay, in a double displacement, the cation and the anion switch places. So the cation is going to pair up with this anion, and this is going to form NaCl. Okay, again, when you form a new compound, be sure to balance your charges once again. With this, you have Na plus Cl minus. Okay, that's already balanced, so you write NaCl with no subscripts. Okay, you do not write Na2Cl2 because Na plus and Cl minus by itself is already balanced. Okay, to balance the equation, you will need to put a 2 in front. That indicates that you have 2 molecules of NaCl. So really you have Na plus, Cl minus, Cl minus. Very important not to write Na2Cl2. It's a very common mistake. Okay, and of course the other cation is calcium, and it pairs up with the other leftover anion, the carbonate, so it forms calcium carbonate. Notice here the anion and the cation is already balanced, so CaCO3. Okay, and of course writing a 2 in front here balances the entire equation, so every element is balanced. Okay, this is what we call the molecular equation. This one right here is called the molecular equation. Okay, to do the complete ionic, you're really just writing down all the ions that are floating around in solution. So the complete ionic is you've got 2 sodiums, so 2 Na plus, CO3, 2 minus, calcium 2 plus. You've got 2 chlorides, so you write 2 Cl minuses. You've got 2 sodiums, so you've got 2 Na plus, 2 Cls, and calcium carbonate. Because it is a solid, you do not split that up, so you should have calcium carbonate as a solid. Okay, remember, aqueous means that these are separate ions floating around in solution. This is a solid. This is a precipitate. A precipitate stands for something that has come out of the solution as a solid, and we'll see this in the video in just a second. Okay, and so in the complete ionic, you do not separate out anything that is solid. All the other ones you separate out into its individual ions. The net ionic is where you take and cross out the spectator ions, and the spectator ions are ions that appear before the arrow as a reactant and after the arrow as a product and as a free-flowing ion. So for example, 2 Na plus, 2 Na plus, you can cancel those out. 2 Cl minus, 2 Cl minus, you can cancel those out. Again, they appear before the arrow as a reactant and after the arrow as the product. You cannot cancel out the calcium carbonate because Before the arrow as a reactant, they're free-flowing ions. Afterwards, it is the precipitate as a solid. So you cannot cancel these out. So after you cancel out all the spectators, you are left with CO3 2-, calcium 2+, and the calcium carbonate solid. Okay. So again, in the lab, we're going to be doing this reaction. So let's do it now. Okay. And we're going to write down what we observe as we do this reaction. And here I've got a 24 well plate. Actually, it's a 3 times 6, so 18 well plate. Okay. And I'm going to add my sodium carbonate and calcium chloride. Okay. So my sodium carbonate looks like this. Okay. Notice it is a colorless solution. Okay. So I'm going to go ahead and add that to this well in that front well here, the first well here. Okay. To that, I'm going to add calcium carbonate. Which I cannot find. Calcium carbonate. Calcium chloride. Sorry, I'm adding calcium chloride, not calcium carbonate. Take that back. Calcium chloride, that's why I can't find it. Calcium chloride is here. Sorry, it took me so long. Calcium chloride is again a colorless solution. So under the observations on your data sheet, you should write calcium chloride as a colorless solution. Okay, I'm going to add that to my well. Okay, and we notice immediately something has happened. Okay, there is a white solid that appears in the well. Okay, and if you want a close up, I'll just bring it up closer for you here. So really, what is that white precipitate? Of course, the white precipitate is your calcium carbonate, because we said that calcium carbonate is a solid, okay? And the NaCl solution is a colorless solution. It is a solution, you can't really see it because of the white precipitate, but if you had let it settle for a while, you will see that the precipitate settles to the bottom and you still have a colorless solution on top. So that is the first one, and for the first one, you'll write Na2CO3, colorless solution. Calcium chloride is a colorless solution. NaCl is a colorless solution. And calcium carbonate is a white precipitate. This first reaction should have already been filled out for you in the data sheet. So I'm just giving this to you as an example. All right. The next reaction that we will be doing is B, which is potassium iodide reacting with lead nitrate. And again, the potassium is K+, iodide is I-, lead is Pb2+. It is Pb2+ because there are 2 nitrates and each nitrate is minus. Okay. As the products, again, you're pairing up the cation and the anion. So I paired up the cation, lead 2+, with the anion, I-. Notice here, I need 2 iodides to balance this equation, and so I have a 2 as the subscript here. This 2 as a subscript means that you need to balance out the cation anion charge. Then of course you need 1 potassium, 1 nitrate. Okay, you don't have any subscripts here. To balance the equation, you do need to put a 2 in front of the potassium and a 2 in front of the potassium iodide here. Okay. As the complete ionic, again, all of these are aqueous. The only thing that is solid is your lead iodide. Okay. Now, how do you know lead iodide is a solid? How did I predict that? If you had watched the lecture video, there is something called the solubility table. And on the solubility table, it says that iodide is soluble except when paired up with lead. So because normally it's soluble, the exception is a solid. So lead iodide is a solid based on the solubility table. Now we're going to do the complete ionic reaction. The complete ionic is going to be all the ions. So K+, 2 of them, 2 of the iodides, 1 of the lead 2+, 2 of the nitrates, and it forms lead iodide as a solid. Again, remember, we don't separate these out into ions because it's a solid. Then 2 potassiums and 2 nitrates. Again, we cross off our spectator ions, the ones that appear before and after the arrow as a reactant and a product. So this would be our potassium and our nitrate. Bring down everything else. Our net ionic is 2 iodides plus lead 2 plus gives us lead iodide. Okay, so let's do this reaction and write down what we observe. Okay, we're going to add our potassium iodide. And notice the potassium iodide is a clear colorless solution. I'm going to add it to my second well. And we're going to add to it lead iodide. Sorry, lead nitrate. Lead nitrate. Lead nitrate is again a colorless clear solution. So I'm going to add that to my second well. And notice right away, we see a precipitate, okay? The precipitate is our lead iodide as we predict. So we should write down yellow precipitate for the lead iodide, okay? And of course, the potassium nitrate is a colorless solution, okay? So that is our second reaction for B, okay? We should write this observation down on the left-hand box, okay? For C, we are going to mix together calcium chloride and lead nitrate, okay? At this point, you're going to have to practice writing the double displacement reaction, okay? Remember, calcium is 2 plus, chloride is minus, and there are 2 of them. Lead is 2 plus, nitrate is minus, and there are 2 of them, okay? So if we're going to pair up the cation and the cation is calcium. I'm going to pair it up with the other anion, which is nitrate, okay? And since calcium is 2 plus and nitrate is minus, this is not balanced, so we need another nitrate, just like we did in the nomenclature chapter. I'm going to give it a subscript of 2, okay? According to the solubility rules, anything that pairs up with nitrate is aqueous or soluble, so therefore it should be aqueous, okay? And we're going to pair up our lead with our other anion, chloride. Lead is 2 plus, chloride is minus, okay? Again, it is not balanced, so we need another chloride, so we need to put a 2 there, okay? Then we check to make sure that the entire equation is balanced. We have 1 calcium, 2 nitrates, and 2 chlorides. According to the solubility table, Cl, when paired with lead, is solid or not soluble. So this should be an S, okay? So based on this, you should be able to write the complete ionic. Again, the complete ionic is bringing everything down. The complete ionic is just Ca2+. It's aqueous, okay? You've got your 2 chlorides floating around in solution. It's also aqueous, okay? You've got your lead 2+, that's aqueous. And your 2 nitrates, and it's aqueous, okay? This gives you calcium, which is 2+, which is aqueous, and 2 nitrates, which is also aqueous, okay? And because this is a solid, we don't split that up, we just write lead chloride, okay? Based on this, the spectator ions are going to be our calcium and our 2 nitrates. So our net ionic is going to be 2 Cl minuses plus our lead 2+, and it gives us lead chloride solid, okay? So let's write down our observations, all right? And we're going to, again, do what we did before, okay? Write down our observations as we do the reaction. We're going to do CaCl2, PbNO3. We're going to add these together. It's going to form CaNO3. And we're going to form PbCl2. Okay? And we're predicting that this is a solid, so we're predicting that that should be a precipitate. Okay? So again, we're going to, and you should be writing this down as you're collecting your data. Calcium chloride. I'm going to do a couple drops of that. Okay, it doesn't really matter how many drops, just as long as there's a sufficient amount to cause the reaction. And we're going to do lead nitrate. Notice for both of these, they are clear, colorless solutions. Notice there is a solid, like we predicted, that is the lead chloride. So here, you're going to put solid or white precipitate. Okay. For all of the other ones, you're just going to write colorless solution. Okay. So, this is our third reaction. Okay. Our next reaction is our calcium chloride and our potassium iodide. For the rest of these, I am not going to do the complete ionic or the net ionic for you. I'm going to just do the reaction in the well plate, and then you need to do the rest yourself, okay? But I will do the actual reaction for you so you can write down what you see in terms of your observations, okay? So you're going to have to do the rest yourself. Hopefully you will join the Zoom time, and we will do the rest together during our Zoom class time. All right. Calcium chloride. Calcium chloride is a colorless solution. Okay. Potassium iodide is also, again, a colorless solution. We've used this one before. Okay. And let's mix it together. Okay. And I am seeing no reaction. Okay. So we predict no reaction. Okay. For D, we're predicting no reaction. That means that this was aqueous and this is aqueous if it is no reaction. Again, you should check your solubility table to make sure. Okay. For the next one, we're going to do sodium hydroxide. And HCl. Okay, and again, both of these are colorless solutions. Oops. Okay, now if you look very, very closely, I don't know if you can see this or not, so I'm going to try and bring the well up closer to you. Okay, there are little bubbles that are appearing, okay, on the side. You guys see the little bubbles on the side there? Okay. So this is an indication that a gas has formed. You guys see the little bubbles there? Okay. This is an indication that a gas has formed. Okay. So in this reaction, okay, what might this be? Okay. And based on your double displacement, you should be able to predict that one of this is aqueous and one of this is a gas. Okay, I'm just going to go that far. Okay, we can talk more about it in the Zoom classroom. Okay. Next one, you have HCl. That's this one. Okay, and again, it's a colorless solution. Okay, and sodium carbonate. Sodium carbonate, here we go. And again, sodium carbonate is a colorless solution. And again, if I bring a camera up real close to you, notice that there are bubbles that are appearing in that well. Okay, this is the carbon dioxide gas that is formed as a result of this reaction. Okay, so right now you should write down for your observations that you see carbon dioxide gas coming out of the solution. Okay. Next we have silver nitrate. And copper chloride. The silver nitrate, notice, is colorless solution, okay? But the copper chloride is a blue solution because of the copper 2+, okay? So it is a blue solution. We're going to add that. Okay. Notice there is a white precipitate that forms. Okay. And I'm going to bring the camera up closer to you. Okay. It's a white precipitate, and then the solution itself is still blue. Okay. The precipitate is white, the solution is blue. Okay. So if you do this one and you do the double displacement, you're going to get AgNO3 and AgCl and CuNO3, and you need a 2 here because the copper is 2+, so there are 2 nitrates. Okay, and then you need a 2 here and a 2 here, so it's balanced. Okay, the AgCl, according to the solubility rules, is a solid. That's the white precipitate. Okay. The copper nitrate is not a colorless solution. It is a blue solution because of the copper 2+. Just like this copper 2+ was a blue solution. Okay. The silver was a colorless solution. That's normal. Okay. So very important to note that the silver chloride is white and the copper nitrate is blue. Okay. That's G. H is HCl, and it is reacting with KOH. And again, I'm going to bring the camera close to you. There are little bubbles that are forming. The little bubbles that are forming is the water. That is a gas. Okay, there should be water. That is the product here. Okay, and again, if you do the double displacement, I'm going to do it real quickly here. The H plus pairs up with the OH minus. It forms HOH. HOH is the same thing as water, and it is a gas. That's the bubbles that you see there. Okay, and K is plus and Cl is minus, so it's KOH. This is the bubbles. Okay, the KOH is just a colorless solution. These two are also colorless solutions. The HCl and the KOH are also colorless solutions. Na2SO4, okay. So sodium sulfate. Sodium sulfate. Sodium sulfate is also a clear colorless solution. And potassium iodide. Potassium iodide, like we said before, is a clear colorless solution. I have run out of potassium iodide. You get a little bit more. Oop. It's a clear colorless solution, potassium iodide. And we're going to go ahead and mix that together. And I am mixing very vigorously, and I am not seeing anything happen. Okay, so I would say this is also no reaction. Okay, when there is no reaction, again, I repeat, there should be an aqueous, and an aqueous according to the solubility rules. Okay, So sodium iodide should be aqueous, and potassium sulfate should be aqueous. Okay. Next, we're going to do sodium sulfate. Again, it's a clear colorless solution. And we're going to add to that lead nitrate. And again, we've used lead nitrate multiple times at this point. It is a clear colorless solution. And notice we have a solid here, okay, that is formed. Oh, I shouldn't have used that. I'm going to redo this again because I grabbed the dirty pipette. Let me do it again. Okay. Apologize for that. Always watch out for what you grab in lab. Could be a dirty pipette. Okay. And we have our lead nitrate. And let's mix it with a clean pipette this time. Okay. And again, we see a white solid there, or a white precipitate. Okay. And again, if you did the double displacement, you would get sodium nitrate, 2 of them, and you would get lead sulfate. Okay. Sodium nitrate is aqueous. The lead sulfate is what is solid. Okay, according to the solubility rules, sulfate is soluble except when paired up with lead. Okay. K is sodium carbonate. Finding these is half the battle here. Sodium carbonate is a colorless solution. And lead nitrate, and this is I don't know how many times we've used the colorless lead nitrate. Okay. And again, we see a white precipitate. Okay. The reason is because sodium nitrate and lead carbonate. Lead carbonate is predicted to be a solid, so that is your white precipitate. Okay. This is just a colorless solution. Okay. As are these two. Okay. And to make it balanced, you probably should put a 2 right there. All right. Next, we have sodium sulfate. So let's do that. Sodium sulfate. Sodium, colorless clear. And a calcium chloride. Calcium chloride also colorless. Okay. And I'm going to get a clean pipette, and I'm going to just stir this around a little bit. Okay. And as I'm stirring, you should see that it's starting to get cloudy the more I stir. Okay. There we go. Okay. So again, we should have a white precipitate here. Okay. It's not the sodium chloride. We know salt water is not precipitating. Okay. It is the calcium sulfate. And again, based on our solubility rules, calcium sulfate is a solid. Okay. So this is my white precipitate. And this is my colorless solution. And of course, the starting materials are also colorless solutions. Okay. M is silver nitrate. And again, silver nitrate is a colorless solution. And we're going to mix that with sodium carbonate. Here we are. Sodium carbonate is colorless as well. Okay. And if you mix it together with a clean pipette, okay, you will see there is a almost yellow, it's a kind of brownish, yellowish kind of precipitate. Okay. Kind of a little bit yellow, okay, but mostly white. So you can say it's a tinge of yellow, but mostly white. Okay. And it's, again, silver carbonate. Why did I write a 2 here? Because silver is plus and carbonate is 2 minus. Okay, so you do need 2 silvers to balance it out. Okay, and sodium nitrate. Okay, to balance this out, you do need a 2 here and a 2 here to balance the equation. Okay, so according to the solubility rules, silver carbonate is a solid, and sodium nitrate is aqueous. The NaNO3 is aqueous. Okay, so the white precipitate that we see here is the silver carbonate. This is again a colorless solution. Okay, let's go on to the next one. Okay, this is going to be our last one. Okay, sodium hydroxide. And potassium iodide. I am all out of potassium iodide. Let me get another container. Potassium iodide, here we go. And again, those two are clear colorless solutions. Potassium iodide is clear and colorless. The sodium hydroxide was clear and colorless. So I'm going to add a couple of drops of that. Okay, I'm going to give it a clean pipette. And I'm going to stir this around. Okay, and again, I'm seeing no reaction whatsoever. Okay, so we would predict, again, no reaction. Okay, and that means that this is aqueous. And this is aqueous, meaning that there's no precipitate, okay? So that predicts that your sodium iodide and your potassium hydroxide are both colorless solutions, okay? Also here, colorless solution, okay? So again, if you missed any of these reactions or what you should have observed, you can always rewind this video, okay? But really, we've done all of the reactions in the table, okay? Your job now is to go ahead and complete the molecular, the complete ionic, and the net ionic on your pages and your in your data and observations. And also, you should write the observations down, okay? In the left-hand column there's a box there in your data, okay? What I would suggest you do is to first go through and just write the equation, write the complete ionic, write the net. Then in your observations, write down your 4 compounds, those 2 starting materials and the 2 products. Then rewatch this video, and as you see me do a reaction, you're going to write down what I'm using, colorless solutions or blue solutions, and then write down what you observe, yellow precipitate, colorless solution, so on and so forth, okay? I hope that that video was clear. Again, we will be discussing more of and reviewing more of how to do the complete ionic and the net ionic in the Zoom classroom. So we're going to go ahead and do that in the Zoom classroom. So after you watch this video, do remember to log on at 9:30, either on Tuesday or on Thursday, depending on whether you're in group 1 or group 2. To finish up this little section on double displacement in lab 4. All right, that ends this video.